Okay, so I think we'll go ahead and get started. John gives me the thumbs up. We're all good in the back. Okay. So what we're going to do is again, like I mentioned at the beginning, take a different approach to what we've done in the past and talk about things in a little different way with smaller groups to have discussion, right? So the whole situation of having discussions is two ways. So we're going to talk, but we welcome comments, questions, etc. So today we're very fortunate to have with us Dr. Mario Bonelli from University of Florida. Mario's been at University of Florida for now 5 years, 4 years, something like that. But Mario is really well known. He had a really strong research program in Brazil before he came to the U.S. And has really been, I would say, one of the leaders with the group in working on things related to Boston-Nicus cattle and Boston-Nicus influenced females. And so today with this section, what we want to do is talk about estrus synchronization and sort of the nuts and bolts and not so much showing one protocol after another and showing here's the results, here's the results, here's the results. We publish those in those sheets, and that's a tool for you to use to make decisions. But what we really want to do is get into depth on how can we increase fertility to single ovulations? How can we increase fertility? What can we do from a producer, from an industry level point of view, to start to increase fertility of our herds, and not so much talk about it, do we use this protocol versus this protocol? These protocols that work, had a lot of discussion about this last night. And if you think about how many cows have been through the 7-day co-sync protocol, I mean, there's thousands, right? And the results are pretty consistent. So now it's about how can we maximize fertility to those single ovulations? How can we get more cows pregnant? What can we do? What are some strategies to do? Where do those differences come into play? We heard about some of it from the panel that we had, that we're going to talk about some of those exact same things. And to really, get you to think, what can you do a little bit different to squeeze 5 to 10% more out of those herds, right? And are there strategies from a sex semen point of view? Are there other type of strategies that we can utilize to get more, capture more value from our herds? Okay, so full disclosure here, Mario and I put this all together, and we hope that we don't have a big train wreck up here. But for the most part, we can also tell some pretty good jokes. So if it all goes to hell, we'll start with that. But anyhow, so we have a layout here, but please stop and ask questions as we go. I stole this slide from Sandy Johnson somewhere along the way, and I use it all the time now. And it's sort of it's what we're here about. Okay, reproductive technology is really a strategy to get genetics into the herd. Right, that's the whole situation. If it wasn't for injecting new genetics and increasing the efficiency of our animals, it would be a situation of what are we doing? And in that, when you think about genetic gain, we've all made positive genetic gain, and we've all made negative genetic gain, right? We've all made decisions within our herds or with our producers that we didn't like those calves, or those didn't turn out like we wanted. Those are situations that happen. So in each of these lanes here, everybody can have a different input in what they want and a different goal for what they're after, right? So if I'm a beef master producer, if I'm a Sangatruus producer, if I'm an Angus producer, my goals are most likely going to be different in my herd if I sell bulls versus if I sell females. And that's okay. It's not a one size fits all. And that's really what the focus of this section will be about. And I think this highlights it best. We're trying to capture this genetic gain, and genetic gain, until we had advanced reproductive technologies, took a long time to capture because of generation interval and selection intensity and accuracy. Genomics continue to get better. Okay, our genomic predictions continue to get better. The more animals that we add into these genomic databases, the numbers are going to continue to get stronger. That's going to affect the accuracy of the decisions that we make. All right. But with reproductive technology and selection intensity and cutting down generation interval, we can make those changes a lot faster. There can be the best bull in the world bought tomorrow. We can have semen collected on him, hopefully relatively quickly, and we can inject those genetics into our herd through AI or IVF or whatever it might be to cut down on that generation interval. So that's what we're really focusing on when we think about this idea of reproductive technology. But we also know that there's a lot of factors that come into play. These are all the factors or some of the factors that affect pregnancy rate. Okay, so when we think about the efficiency at which we're able to accomplish this, there's always going to be factors that help us increase efficiency, and there's ones that are going to negatively impact efficiency. And so, for example, heard a lot about facilities, right? If you're in bad facilities and you're trying to do artificial insemination, that could negatively impact you as the inseminator or negatively impact the temperament of the cow. I'll never forget when I was at University of Tennessee, was out at a producer's place. First cow came in for the AI in a normal head catch and put my arm in the cow, and the cow walked off with the front gate of the head catch. She was gone. She had it wrapped around her neck. I was just standing there. And Jay is laughing because he knows this is a true story. So, these things happen, right? And so it's something as simple as facilities to take the stress out of us as the person working and out of the animals from a handling point of view, all have impacts. And that's one of the reasons that it's so difficult from a reproductive efficiency, reproductive management point of view, because we have to control so many variables. I think it was Luke that said, the more control we have over the more variables, the better off we are, right? We would like to be able to control everything and we'd have a lot more success. But the reality is we can't control the weather, okay? We can't control, droughts. We can't control these type of things that are going to affect our cows from a nutritional point of view to get them in the right situation. So a lot of factors, and we're going to highlight some of these today. Whoops. And before I turn it over to Mario here, this is an image of what the day 21 and day 31 pregnancy look like in a cow from a histological point of view. And I just showed this because it's rather complex. There's a lot of changes happening. If you look from day 21, where you can see the uterus in blue, you see the lumen where the embryo is going to eventually develop. The placenta is in red there. When we move to day 31, you see the placenta starts to show green. Have a lot of changes happening, a lot of communication between the cow and the developing conceptus, but there is a lot taking place, right? So when we sit back and we think about, when I think about getting cows pregnant and maximizing fertility, it's like, we've come a long way in a short period of time with these protocols, with reproductive technology to achieve the pregnancy rates that we have today, right? And so now it's how do we get more of these successful pregnancies develop? How do we maximize fertility to a single ovulation? Because it's not so much talking about anymore, how do we get cows to ovulate? How do we do this? We're doing a pretty good job at that happening. Now it's how do we get more cows pregnant from those ovulations? Is it on the semen side, which we're going to talk about later today and tomorrow, semen handling, what effects come from the bull? Is it more from the cow side, which we're going to talk about this morning with some of Mario's stuff? But it's putting all those pieces together and all those factors together to maximize success. Okay. So Mario is going to cover a little bit about estrus synchronization, sort of a recap of what we know. And just remember that, these protocols have over 50 years of understanding of the estrus cycle built into them. Right. So a lot of people and a lot of pioneers in the field, some in this room, spend a lot of time characterizing the estrus cycle of the cow so that we can manipulate it, so that we can do things that we do today to control when a cow is going to ovulate, when she's going to come into heat, etc. All right. So with that, I'm going to turn it over to Mario, and he's going to cover a little bit about the estrus cycle of the cow.
Thank you, Kai. You guys hear me okay? It's a pleasure for me to be here. Thanks a lot for the task force leadership to inviting me to share some of my thoughts. And I'm really looking forward to have a lot of fun with Kai during this presentation on our back and forth. Please be patient with us. I'm an assistant professor in reproductive physiology at the University of Florida, Department of Animal Sciences. As he said, I have a previous history working in reproductive physiology. That's what I've been doing since I finished my PhD a long time ago. So I thought and discussed with Kai about just doing a recap on estrus synchronization concepts. We'll assume that many things will be known by you. If you don't know the very, 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 very basics, just come to the session that's going to be this afternoon. We'll go from the very beginning. But anyhow, I decided to just recap some of the concepts. So the big thing here is that what we know from the very, very basic, just from observation, is that it takes on average, 21 days for a cow to show heat, like this one is showing right here, standing to be mounted, and for her to show heat again if she's in good health, and if she's not and if she's not bred, she's not exposed to a bull or to AI. So that the 21-day interval in average revolves and is going to repeat over and over. How come? It must be a regulated process. Why it is not random? Why it is not 10, then 30, then 17, then 12? Because there are lots of things happening in the ovary and in the uterus of those animals that are set up by nature, by evolution, so that that estrus behavior will repeat at every 21 days. Again, I'm not going to go through the whole process. Probably you guys here in this room have seen this picture many, many times before, but I'll show a few key characteristics. Within the natural cycle, at 21 day on average cycle, there'll be waves of follicle development. So on these example, this is a cow of 3 waves: first wave, second wave, and third wave. In cattle, there will be usually 2 or 3 waves, sometimes 1, sometimes 4 and 5, and the vast majority 2 or 3 waves. Most important wave is the last wave. And the last wave, which could be the second or the third, is the ovulatory wave. It's the wave that will produce and release an oocyte. They'll be ready to be fertilized if she's bred, if she's inseminated. So studying the patterns of follicle growth, follicles that emerge, reach maturity, and then, in this case, do not ovulate and regress. But most importantly, on that last wave, that wave in which you see again follicles are recruited and start to grow, and then one is selected to become the dominant, and that is the one that ovulates. Especially studying that last wave, most of the concepts on synchronization emerged. And if you have questions, maybe you can stop and discuss some of these. So on that last wave, and again, what is most important is the phenomenon of ovulation. So there'll be a program that will happen at the very end of the development of that last wave. So there'll be the final growth of that dominant follicle, that last very large follicle that we see here. And you can see that the oocyte is right inside, and that follicle is growing. And that follicle produces one predominant hormone, which is estradiol. Estradiol makes the cows come in heat, acts on the brain, makes them change their behavior, and now they stand to be mounted, and now they walk more, now they talk more. So it's something that happens in the brain. It's a behavior change, and most importantly, will make them stand to be mounted. If there's a bull around, he'll know it, and he'll bred her. If there's no bulls around, that's us, and she has an astral attack, for example, she'll be mounted and will be detected that she's shown heat. So here's an astral attack. So for management standpoint, for example, she will stand, and because of that, cow will be rubbing her chest onto her back, and remove that paint, and we as managers or scientists or producers will be able to tell that that cow is in heat. If you could detect the very initial moment that that animal started her heat behavior, 28 to 30 hours to the clock, she'll ovulate. What is ovulation? It's the release of that egg. It's not anymore inside that follicle. Now it's been ovulated. Now it's in the reproductive tract of the cow, in the oviduct, ready to receive semen and be fertilized. That's going to happen about 28 to 30 hours right after the beginning. That's a picture from a human ovary. We don't have that from a cow. I look for that exact moment of ovulation, the expulsion of whatever the contents are of that, all the follicular fluid that's inside that follicle, and also the expulsion of that oocyte, so that it will be fertilized. And then, of course, there'll be a remodeling of the cells that used to form that follicle. and that will become the corpus luteum present on the next estrus cycle. So estrus synchronization is management of the ovary, of these two basic structures. Follicles that, as I showed on the previous slide, grow and regress, and eventually ovulate, and management of the corpus luteum, which is a result we can see here in an ultrasonography picture, which is the result of the ovulation. So after that big follicle ovulates, on the next estrus cycle, there'll be a corpus luteum present. It's right here, and follicles will remain growing, following a dynamic that I showed you previously. That's waves growing and regressing. Okay, this is the end. This is the end of the estrus cycle. She's showing estrus, or the beginning of the next estrus cycle. She will show estrus, she'll ovulate, and that is exactly what we want to try to manage. Either with both, we shouldn't have to do anything, they'll do it for us, or through AI. So when that's occurring, so that will sync our insemination practice to the moment that oocyte is released, so that we'll have time for capacitation of the sperm, and then fertilization, and then for a pregnancy to ensue. That's the very basic of it. Good. So when we're trying to synchronize, when we're trying to establish protocol, design protocols, we actually want to do is an attempt to mimic the events of the ovulatory follicular wave, which is the last follicular wave of the cycle. Okay, and we're going to do three things. We're going to try to program follicle recruitment so they are not all over the place. We want to know when that last follicle wave will start to grow. We like to program that. Second, we need to induce CL regression. As long as there is a corpus luteum present, as you can see here by this orange line, there is no ovulation. The follicles might grow, but they will not ovulate if progesterone is high. So we must kill the corpus luteum, induce CL regression. And then after we do that, the follicle that we recruited here will continue to grow and will be allowed to ovulate. We can stop right there. It will ovulate spontaneously, but we like to time it. So if we want to time it, to do time AI, then we need to induce ovulation. It will happen spontaneously, but it will happen not in a synchronous way. If you want a more advanced protocol in which we have time AI, we like to induce ovulation, and that is the third step on most protocols, at least the simple ones. Is that clear, everybody? That's it. So what people, many years, the pioneers that Kai talked about, when they were ultrasounding cows every day and trying to figure out how these follicles grow, to boil it down to something practical, these are the three steps that they figure out, okay? Program follicle recruitment, induce CL regression, and then induce ovulation. So mimic that last wave of follicle development. Very good. Then a set of tools is being created. And I don't work for any company. Whatever I have in my hand, I took a picture. So please, any of these drugs that are listed here are the ones that are approved to be used in the United States, and they will, if they are used on compliance, they'll serve the same purpose. So the drugs that we have in our toolbox that can be used to achieve that synchronization goals are prostaglandin F2 alpha, and here are some of the commercial products. GnRH, and here are the products. We use a source of progesterone or a progestin, like a CIDR device that's progesterone, like MGA, that's a progestin. It will act like a progesterone to the cow, but it's not progesterone, it's a progestin. And then tools to detect estrus, such as a patch like I show here. How can we put these tools together in a protocol? And again, I'm just talking a basic protocol that have many different variations. So before AI, here's a moment of AI. The first thing we want to do is to program follicle recruitment. The way we usually do that is through an injection of GnRH. So the idea is that if there is a large follicle, that GnRH injection will cause its ovulation. And then after it's ovulated, it will lose its dominance. Then after losing its dominance, a new wave of follicle recruitment will occur. So that's a response to removing the dominance of a dominant follicle that's present there. So that's how we use GnRH. And we also insert a progesterone releasing device, such as a CIDR. Good. Here's some of the products. So here's a CIDR that can be used. We want to eliminate an eventual. That's through that injection of GnRH. Next, the second step is to induce corpus luteum regression. Why? If there is a corpus luteum, there'll be progesterone. If there is progesterone, there is no ovulation. There is no heat. Okay? The progesterone blocks heat and blocks ovulations and successful release of an oocyte for fertilization. That is done by an injection of prostaglandin. Prostaglandin will kill the corpus luteum, will cause a reduction on the endogenous progesterone concentrations. And then at the same time, we will remove that progesterone releasing device. As we do that, we make concentrations of progesterone in the blood very low to almost none. And that's a requirement for that follicle to continue to grow and reach the size of ovulation. That's one of the products that can be used. Then last step, because that follicle grew in the absence of progesterone, we like to induce ovulation. So here's your big follicle, that one that grew from the recruitment, from that first injection of GnRH, then it was able to continue and finalize its growth under low progesterone because we kill the corpus luteum and remove the CIDR. And now that cow is ready to show heat, and we are ready to program its ovulation for time AI or for AI based on estrus. And then the product that we're going to use at this point is going to be, again, an injection of GnRH. Could be that one or any other one, as long as you follow the recommendations of the manufacturer. We put that together in the very classic protocol that's is not the oldest one, but one that really put a lot of popularity to estrus synchronization, which is the ObSync. So an ObSync, and this one doesn't even have a CIDR. There's a first injection of GnRH to cause the ovulation of a large follicle that's present on the ovary. That will start the development of a new growth of a new follicular wave. They will grow. After 7 days, you will kill a corpus luteum using an injection of prostaglandin. And then that protocol is being changed, but I'm showing you a classical version of it. 48 hours later, there was an injection of GnRH that will induce the ovulation of that follicle that we induced to grow. And then time artificial insemination was recommended at that time 16 to 24 hours later. So that's it. Very simple. Those three concepts: recruit, remove prostaglandin, induce ovulation, and you have the basis of most of the protocols that are out there. I would say all of them. Very clear? Anybody can do this.
Hey, Mario, so with that, one of the things that you talked about was all these tools in these toolbox, right? So one of the questions that we get very frequently and ask the expert is, okay, I gave these drugs and the cow didn't respond. Are the drugs good? Are the drugs working? And so, one of the things that I think you pointed out when you highlighted the prostaglandins, the GnRH is available, the progestin is available. If those products are handled properly, for example, if you follow the label for storage, if you follow the label for use, these products are very effective in their ability to do what they say they will do. And so my point is that it's very, very, very seldom that there was anything wrong with the production of the product. It's most of the time improper handling or improper use of the product. And I'm sure, folks from the drug companies in here can definitely, stand up and say the exact same thing, that, it's someone left it on the dashboard of the truck, 110 degrees, and then gave it to the cow and got no response. So I think it's really important to keep that in mind. And then one of the questions I wanted Mario to address is, you highlighted the let's say the accuracy around the time of ovulation from the onset of estrus. So can you just address that and how much variation there is in that system, and then how much variation there is after we give a GnRH, if the follicle is large enough to respond to the GnRH to ovulate? Those two things to think about sort of timing as we move forward in this discussion in regards to these protocols.
So the system that we use at University of Florida, and it has been used for many, many years, maybe like 10, 12 years in our herd, our research herd. I'll tell you more about that herd, about 350 multi-breed animals, is the 7-day co-sync plus cedar. But what the manager does after he removes the cedar, injects prostaglandin, he checks for heat. He checks for heat 2, 3, 4 times a day. And he first inseminates based on heat. Then after 84 hours, because that did not show heat, he'll give an injection of GnRH, and then he'll inseminate what we call time AI at that point. What we observe is that there is a very large dispersion of the moments of heat behavior. And because he is observing many times a day with all the failures of human observation, he uses an Estrus detection patch, there is a spread. So although at some point on the past, there used to be a fixed time AI, because of suboptimal results, we decided to try to do the best we could to try to maximize fertility, and that was inseminated based on heat. So it's like a step back of the technology that has been developed and that this group praises, and we have in our protocol sheets. But there was more of the reality of the producers we see in Florida, and actually a way to try to maximize the result in terms of fertility. And I have to say that because that's the truth. We are kind of sticking to that, at least up to this moment. We didn't take the next step to do time AI in all of our cows, because when it was done before, the results were less than what we were doing based on estrus. They'll not be practical in many operations. Many people will not do it if you have to do daily estrus observations. Because it is a research herd, we are still doing that. And again, we do observe a variation which would compromise or at least decrease some of our results if we did a single time AI. But there are ways to go around that, like Guy is going to talk about.
Yeah, and I think the point that Mario really emphasized there is, so what we see in the textbook and what we talk about all the time is an average, right? And what a majority of the cows will do for timing of ovulation in regards to estrus and timing of ovulation in regards to GnRH. But just about all of us in here, I mean, I like to think I'm normal and in the average, but probably most likely I'm not for some things. And so those cows fall on different sides of that bell-shaped curve. So some of them are going to ovulate a little bit earlier, some are going to ovulate a little bit less. And with timed artificial insemination, I'm going to show the slides today, we pick sort of the optimal time to go in there. But it also makes sense, which Mario is going to talk about, is that you get this benefit if you do any type of estrus detection and breed sort of cherry picking those cows. Of course, they're going to have better fertility because we're catching them at the optimal timed AI versus if we would have waited to the time AI to do that. So just things to think about in regards to sort of how that works. So, the thing that Mario mentioned is there's been a lot of work to get to this point. And to really boil it down, to think about what's captured in these sheets here, the estrus synchronization protocols, there's hundreds and thousands of publications that have gone into generating these protocol sheets. And we had a lot of discussion about this last night, about the complexity or the simplicity of these, how you sort of manage these sheets. And, sometimes I sit back and I look at these and think, wow, there's been a lot accomplished in reproductive management for beef cows. To be able to look at these sheets and see where we went from something as simple as using a GnRH and prostaglandin combination with no progestin whatsoever, all the way to having a protocol that we can achieve acceptable pregnancy rates in Bos indicus influence females, to being able to have protocols that have more complexity to them of some type of pre-synchronization, and really, the tried and true that we see used over and over again, something like the 7-day co-sync plus CEDAR protocol. And, when the protocols go on these sheets, the important thing to keep in mind is that they've been evaluated in multiple situations, multiple environments, all types of herds. I think it's really important to know that, we look at these protocols from an approval point of view. We want to see them utilized in the best herds, and we want to see them utilized in suboptimal herds, because they need to perform to the best of their ability, no matter what the herd is. Now, there's going to be variation, but we need to see results coming out that would suggest that this is going to work, that it can work over and over again. And so when something goes on here, I would just say that, you should have a high confidence level that we have really given this a lot of evaluation. And you're going to see these protocol sheets change. We voted on this last night. You're going to see updates coming out to this with more protocols added or redesign of the sheets. And we hope that in that, it doesn't make it more complex. We take a more complex topic and make it simpler for people to understand, I think is what we need to be after. So we have the cow sheet. These are the current protocols that were approved last year for the cow sheet. And we have the heifer sheet. Okay. And, I would say that, and we heard this from the panel this morning, one of the big questions that I always get, and I think we get on Ask the Expert tab and get asked all the time, is like, what should I expect? Okay. So, if I would have came here today knowing that they were going to drill a hole in the floor downstairs, I wouldn't have been so distraught when the drill started. But I didn't know that, right? So when we show up for an estrus synchronization protocol and a producer is expecting something, it makes it a lot easier to manage that situation. So, for example, when I ask students the first day of class, like, what do you want to get in this class? So they set a goal, right? It's an expectation that they're going to achieve this. And if we think about working at it from that point of view, when we achieve that expectation, which I think we should start with an average expectation and then try to increase from there. I think one of the biggest mistakes we make in a reproductive technology situation is setting that first bar too high. It's always easier to set it at the average and work up from there. It's very difficult to start it too high and have to talk down to the average. A producer doesn't get very happy about that, right? So I'm going to show you what, and then we have the sex semen protocol sheets, which I'll talk about a little bit later, but, advances in sex semen and highlight that. So this is some work that one of my PhD students, Sydney Reese, who's has graduated and moved on to greener pastures and going to talk later today, representing 44 farms. Sydney had this idea to go through basically the literature for the last 30 to 40 years and summarize what the fertility in the modern beef cow herd was. All right. And the reason for this is a lot of us cited a paper that was published in 1978 for fertility, pregnancy loss, and embryonic mortality. And so Sydney took this on, went through all the literature, went through 40 years of data, and ended up with over 100,000 records that were then sort of mined through to make sure that we had pregnancy diagnosis done at the appropriate time, that we knew what was going on in the experiment, we knew what type of animal it was, whether it was Bos indicus or Bos taurus, whether it was a heifer, a primiparous cow, or a multiparous cow. We knew what the breeding method was, whether it was breeding based on the AMP rule and estrus detection, or fixed time AI, or embryo transfer. So we knew a lot about these studies, and a lot of the data we had generated in recent years. And so what this shows is, it shows percentage of embryonic mortality in the first 30 days of gestation, right? First 30 days of gestation. So let's look at this. So the first one is parity, and I'm going to transition this into pregnancy rates, okay, for those of us that can't do math well, which I can't. So I'm going to do it and just do it for you here in just a second. So nulliparous, periparous, and multiparous, right? So this is number of groups of animals. This is not number of animals, okay? There's over 50,000 animals represented in this slide right here. So this is number of studies. So there's 49 studies that we gathered data from on heifers, 17 primiparous cows, 39 multiparous cows. So if you look, I don't think it's a surprise to anybody in here that primiparous cows had the highest amount of early embryonic mortality. So they were losing pregnancies at a higher rate compared to virgin heifers and to multiparous cows, which we know a primiparous cow is one of the hardest ones to manage in the cow-calf sector, right? They're raising a calf, they're still trying to grow themselves, and we're putting pressure on them to get pregnant. So not surprising there. Bos indicus versus Bos taurus. Okay, so this is percentage Bos indicus all the way up to full bloods, and then Bos taurus cows. Bos indicus cows, Bos indicus influence cows have higher early embryonic mortality in the first 30 days of gestation compared to Bos taurus cows. And when I first showed this data, people used to throw things at me saying, oh, Bos indicus cows, or you're saying that they're less fertile than Bos taurus cows. No, I don't think that's what it is at all. If you look at where these 43 studies are done versus where these 55 are done, if I put those Bos taurus cows, like Vitor said this morning, into that environment where those Bos indicus cows are, they would die. All right, so they wouldn't survive. There's environmental factors that come into play that make it more challenging to manage Bos indicus females. And Mario is going to highlight that with what they're doing at the University of Florida with their Bos indicus influence herd. And so the whole point is that, again, it comes back to reproductive technology that we can't manage everybody the same. We can't even manage two cows the same. A Bos indicus influence cow is very different than a Bos taurus cow. And we have to utilize different protocols to make that successful. And until we develop, let's say, better reproductive management strategies for some of those Bos indicus females, we have to do things like a little bit of cherry picking and estrus detection in AI and time AI to get that same level of success. Breeding method. AI versus the AMPM rule versus fixed time AI versus embryo transfer. Again, not surprisingly, embryo transfer has the highest amount of embryonic mortality in the first 30 days compared to fixed time AI, and then compared to AI based on the AMPM rule. And you're going to hear Mario and I say this a lot today, is that one thing that you cannot replace in all of these protocols is a cow showing estrus. So when a cow shows estrus and she's bred at the appropriate time, it's like the gold standard. That's why, you know, estrus detection tools, things like EstruTech, have become so popular even in fixed time AI protocols, because they're like insurance policies. You show up and you get there, and like the worst situation in the world is you step out of the truck for the day of AI and there's like 10% of the cows in heat. You almost want to stop and just cry right there. We know what the reality is of that, right? But we can start to talk to the producer that day about what that reality might mean. Instead of not knowing what's happening, breed all the cows, have lunch together, you're all excited, and then 45 days later, you get that phone call that is not so exciting. So that's why I'm showing you this from a realistic expectation point of view. So what does that mean for pregnancy rates? So all I did was take 100%, subtract out the embryonic mortality. So on average, in this data set, in a multi-parous cow undergoing some type of reproductive technology, average pregnancy rate at day 30 to a single ovulation is 52%. So if I asked you all in here today, if you could achieve 52% in your herd every day of the week, if that was the average, would you take that? And I would hope the answer is yes. So 52% is a good average. It's almost like achieving a high C, a low B maybe in a course, right? And then there's always room to build upon that, right? So when I see some of our better herds hitting the 70%, 68s, 65s, whatever it might be, and then the producer says, well, I hope we can do better next year. It's very difficult to start to squeeze those extra percentage points the higher you get above that average. And in fact, a lot of reproductive biology is a tricky situation because we try to do something better and we actually get 5% less. So you start to get in a situation where you go back and forth in these percentages. And so I show these because I think these are the realistic expectations. In a prairie-paris herd undergoing some type of reproductive technology, 45% pregnancy rate at day 30. Again, a high percentage of those cows were not cycling the first day of the breeding season. A high percentage of those cows are still growing. Maybe it's partially our situation of getting them to the right body condition score, et cetera. But again, 45%, pretty good. Okay, let's look at the next 30 to 60 days. So let's get us to day 100 of gestation. So let's say the modern beef cow herd, if you don't have some major disease insult to the herd, pregnancy loss drastically drops off at day about 60 to 75 of gestation. Now, if you get BVD or you get trick or something like that, then that's a different story. But normal pregnancy loss does not happen very frequently, less than 1% after about day 75 to day 100. So what happens in this next 30 days? So what's the pregnancy loss in this point? Overall, the estimate across all the animals, all the technology is about 6%. Subspecies, no difference. Nulliparous versus prairie-paris versus multiparous. Virgin heifers have a higher amount of pregnancy loss in this period than any other category. It's about 8%. I just spent the last 2.5 weeks in South America, and this is the #1 topic as you go across South America right now, because everybody's recognizing in their virgin heifers and their nulliparous heifers that pregnancy loss is higher in those animals than any other category. And when I look at it, it's not a surprise because we have this data to show that. I think we're doing a better job detecting it. Okay, we're recognizing it's happening, but also we're putting a demand on those heifers, specifically in Boston-Nicus influence heifers, that we have never asked them to do. So Mario can share a little bit about their experience with heifers, but if you think about something like Brahman, if you go from breeding those animals at 16 to 20 to 24 months of age, and then drastically you go and say, okay, I'm going to try to get you bred at a year of age, that is a drastic difference, right? It's not a gradual change, it's a drastic difference. And so I think that's one of the effects that's playing into that. And then a lot of us have data. George Perry has data, we have data, a lot of people in this room have data to show as you nutritionally develop heifers and you manage them of transitioning them onto grass, different things like that, those are all factors that can play into that. So normally we try to take really good care of our heifers and developing them in a way that makes us happy, but we have to remember what the long-term goal of them is in that situation. So I think that's where that's coming from. Breeding method, fixed time AI compared to embryo transfer, about 5% in fixed time AI, about 10% in embryo transfer. And I will tell you, it makes a big difference if you're using conventional versus IVF based embryos. You can almost double these numbers. And we have a herd right now that's running in the 40% pregnancy loss during this time point. It's the worst I've seen, but it happens, right? These type of situations happen, and especially when we look at it in regards to embryo transfer. So what can I walk out the door with on day 100 for an average pregnancy rate? And again, the modern beef cow. So if I am only managing prairie-paris cows and I'm trying to set an average pregnancy rate on day 100, what the data shows is the average of the data that we look at today across all these studies would suggest on average a 40% pregnancy rate from a single insemination to a single ovulation on day 100 of gestation. So if we go into a situation with prairie-paris cows and we say, Mario, I'm going to synchronize these cows with prairie-paris and I want to achieve a 65% pregnancy rate, it's like, let's have a conversation about it. The data would suggest that we're going to be on average about 40 to 45%. Anything that we get above that is a huge benefit. Versus if we start with the mentality that let's get 65% and then we get 40, it's a lot harder conversation to have. And you can look through this on any of these And if you just look at Bosindicus, for example, Bosindicus influenced females, you say, what's a acceptable day 100 pregnancy rate to a single ovulation? It's 45%. And I'll tell you, in the herds that we work with, this is like right on. This is what we see. If we can achieve 50% at day 30, have a final preg check from that single ovulation at about 45%, they're really happy. Because a majority of these females came into this breeding season not cycling and would have had no chance to achieve this without tools like estrus synchronization and AI. So again, I know based on everyone's look out there looking at me like this guy's crazy, that these numbers seem low. But remember, this is the average. This is what the average of the herd looks like. And so we have a lot of room to build from this going up and building on how can we improve these. And hopefully in another, it doesn't hopefully take 40 years to reanalyze all the data, but in another 10, 15 years, we can circle back around and see increases in this. You know, if you look at the dairy data, for example, so you look at people selecting for milk production and dairy cows, and you saw the fertility line go like this over a number of years. And then all of a sudden, people realized fertility was bad in the dairy cow. But if you look at it, the trend line was very clear, right? And through genetics and reproductive technology, that has changed. And so we're looking at this line today, and you know, others have reported similar findings of a decrease in fertility in some populations. And I would say there's things that we can do today from a management point of view, holistic management, putting nutrition, health, all these things together to increase these numbers. So this is the baseline. So in 10, 15, 20 years, we'll measure the fertility of our herds based on some numbers like this. And I think it's really important with the herds that you all work with or within your own herds to set a baseline. Figure out where you've been. What's my goal? What do I want to achieve? Do I want to get 5% better? Do I want to get 10% better? What are the strategies to make that happen? And so again, just the realistic expectations of what that looks like. And so I guess I would kick it to you, Mario, and say, you know, in you guys' experience, when we look at Bosindicus influence animals, we all struggle with this idea of timed AI to maximize fertility in those animals because they're a different beast, right? Luke highlighted that, you know, they're just a different category of animals. So what's some strategies that you guys have utilized in regards to maximizing fertility in these type of animals, and how has that worked with the stuff that y'all done at University of Florida? And again, if people have questions, just raise your hand and stop us, right?
So to initiate this discussion, I will introduce you to the University of Florida multi-breed beef herd. I'll talk a lot about that herd. It is a very unique herd. It's been there for about 30 years and is a balanced admixture of Angus and Brahma. That means go from straight Angus to straight Brahma with all the crosses in between divided in 1/30 seconds. Okay, so by genetic evaluation and by knowing the breed, the matings, we know exactly for each of these animals what is the proportion of Brahman, what is the proportion of Angus in the 1/30 seconds divisions. Is that clear? 1/30 second, 2/30 second, 3/30 second, all the way to complete Angus or complete Brahman. Very good. And I kind of jumped the gun here, but this is Danny. This is the manager of. He was the manager of this herd for many years, and that's the protocol that has been used at University of Florida for at least the last 12 years. So again, is GnRH, cedar, remove the cedar, give a prostaglandin, just like I described to you. Estrus many times every day, and he'll breed AM PM rule based on estrus, and then 84 hours after he removed that cedar and gave the prostaglandin injection, the ones that did not show heat, he will give a shot of GnRH and do a time AI. On these animals, I don't think I have that data here. The fertility to the cows that were inseminated in estrus, it's 62%. The fertility of the cows that here is 25%. So the ones that did not show heat, but we're still getting them to do it, they're going to be less fertile. But that gets back to that point of the estrus as a mainstay, as a hallmark of fertility. And if you can do, based on estrus that is detected by any means, it's beneficial for you. And this is the data that we have summarized, and we put that into an extension publication, which just shows which just show for each of the categories in our herd: yearlings, 2-year-old heifers, primipares, 2 years old, secondipares, and multipares. What is the pregnancy to that AI? That again was based on estrus, except the last ones that did not show estrus, and will vary from those rates. And in our multipares, yeah, it's 50%. And at the end of the breeding season, so 10 days after that AI, the bulls are introduced in a herd, and they remain for a total of 90-day breeding season. And then 30 days after the bulls are removed, we do a final preg check. And these are the actual pregnancy rates for each of these categories on that multi-breed herd. So I like to show that, especially when I'm in Florida. Because, okay, this is our data. This is data from our data that we obtain in our condition with our kind of cattle, which is a multi-breed. So Florida is mostly cow-calf, and I would say, Tim, I think I'm not wrong, 95% they have influence of Bos indicus of some degree. And then you show this information, and that serves as that average baseline that producers can look and can say, okay, I can do better than that. No, I can be close to it. And how am I doing comparing to this benchmark that is set up at the university? So it's good to have real data and not data that's just here from, from your neighbor or from outside of the state. So I put a lot of emphasis on this, and I show to say, okay, if you want this, if you want to have expectations, this is how well we are doing at the university. And then you can measure up.
And Mario, one of the questions with that, so I think you highlighted the data, but if you go back here and you look at the AI results.
Oops, sorry.
Oh, you're fine. You look at the AI results. That includes the AI from the estrus detection and the time AI at the end, right? Yes. So that's both summarized together. And so when you look at those results, and Mario already said this, most of those pregnancies are coming from those cherry-picked animals that are in estrus, right? Now in the Select-Sync plus cedar, you're dragging out that estrus detection a little bit longer and waiting for that time AI versus what we do like in the 7-day co-sync. But just if you look at the differences in those animals and the ability for them to get pregnant, and then look at the overall pregnancy rate, remember there's a lot of work that went into it because there was a lot of estrus detection that got to that point. So any questions at this point, or yeah, Tom, go ahead.
Yeah, just looking at your graph here, I mean, I think we all in the industry realize in that 2-year-old we bred is probably the toughest animal we have, but why decrease there on the 4-year-olds? Any idea on what happened there?
In the final pregnancy rate?
Yeah.
This,
down to 75.
this guy's here?
Yeah.
No, I don't have an explanation for you. Maybe a low number, 52. But I'll have to look at multiple years to be able to give you a good conclusion. Maybe that's an exception. I wouldn't expect that. That's what I'm trying to say.
Other questions? So,
well, I had a question on the previous slide. Can you reiterate whenever you said the ones that didn't get bred in between like 72 to 84 hours? Did you give the GnRH and then wait a few days, or did you AI and then give the GnRH?
Then we give GnRH at the same time we AI.
So regardless if she was showing E throughout that period, if she didn't show anything, you just did it at 84 hours, AI, GnRH, and you're done.
So everybody that showed heat between cedar removal and that 84-hour, we do breed in the AM PM rule. Shows heat in the morning, we AI in the afternoon, and vice versa. The ones that at the end of those 84 hours did not show any heat, they still receive a shot of GnRH and get bred and hope for the best, which is 25-28%.
just
But
Did you give a shot at GnRH and anything that expressed estrus that you bred in between?
no.
Is that your question as well? Yeah, I think that's a really good question. It's like a lot of times we've already bought the product, right? So we have it sitting right there, and it's always a debate as to whether you give it or not. And a lot of times I personally don't give it. Sounds like Mario and them don't give it either. I know people that give it. I don't think there's been any major data set that shows a negative impact in a true comparison of giving GnRH to animals that show estrus that I'm aware of. I'm not sure if you know any. George, do you know any? I mean, so a lot of times it's like you think about from a producer point of view, we bought the product, right? So it's not like we're going to give it back. So we might as well just use it. But it's something that I struggle with just a little bit. I think it's a really good question. Any other questions on that topic? So it really leads us into this point. Well, what about time AI and how? So we see this situation, right, that is working fairly well on a Boston Icus influence herd, and we start to think about, okay, time AI. How does this really work? What's the work that's been done in regards to getting us to this point of the different categories that fit for a time AI? So there's really three situations. We have estrus before insemination, which is where essentially you have these animals that are in standing estrus, they have an LH surge, and then they're going to ovulate 28 to 30 hours after that LH surge. And we have this situation where that egg that they ovulated has some lifespan to it. Okay, in this case, I'm showing about an 8-hour lifespan. And the sperm that we put in the reproductive tract has to undergo capacitation and then can have the ability to fertilize. So we have this situation that estrus before insemination at some point is good. We just don't want it to be too early, right? Because the main key in a fixed time AI program is the lifespan of the egg and the lifespan of the sperm have to overlap. If they don't, there's no magic situation that's going to happen, right? The timing has to be appropriate. And that's why the timing on these protocols is key. Protocol compliance is key. And a lot of people have spent a lot of time fine-tuning the numbers in regards to timing of AI to overlap these two situations right here. Now, if we look, okay, what about a situation that the animal does not show estrus? So what do? Okay, so we induce a GnRH surge with LH. At the same time, we put the sperm in the reproductive tract. That cow is going to ovulate some period after that LH surge, 30 hours later, usually 24 to 30 hours, and then that egg is going to have some lifespan. But the overlap here is not the same as in the situation when the animal spontaneously came in estrus off these protocols. So when you see all the data, and a lot of us have summarized a lot of data showing that animals that are in estrus, for the most part, tend to do a lot better in fixed time AI protocols. And when you breed them based on A and PM, when we saw the data there, it's very clear, right? And Mario's data and our data, that you get higher fertility. And this is the reason. It's because we're battling this situation of fertile life of the sperm and fertile life of the oocyte. So things like delaying insemination, all these, which I'm about to talk about, are what help sort of bring those windows closer together and to overlap them to make that happen. All right. So let's look at these a little bit. So in a situation of pure fixed time AI, this is unfortunately a very busy table. This is work that was done at the Texas A&M AgriLife Research Station down in Beeville when Gary Williams was there. They spent a lot of time working on BSync 1 and BSync 2, which is approved on the protocol sheet as the PG 5-day co-sync protocol for Boston Icus influence females. And if you look at that, and in their data, they were doing pure fixed time AI. Okay, no estrus detection. They put estrotech patches on, but they were just determining who was in estrus or not. And what you can see in all of this data is you see a percentage pregnant over a number of years shown here of 51.8% to time AI in Boston Icus influence females. Now, if you really dig into the data and you look at it, the majority of those pregnancies are coming from females that showed estrus compared to the ones that did not, right? And so what are some strategies that we can do to maximize fertility in a time AI protocol, okay, with the time AI mentality, but making decisions behind the cow. So what we've done is we've used Estrus patches for a number of years. We've scored them in a system to try to determine, what was really the difference in fertility. So we started this a number of years ago in 2009, 2010. And we'd score the patches on a 1, 2, 3, or 4 system. 0 to 25% of patch rubbed off, 2 to 50%, 50 to 75, and 75 to 100, which was the patch was clearly 100% rubbed off. And then we would say, okay, this animal has low estrus expression or no estrus expression compared to animals that had higher estrus expression. So, basically separating those two out. And we summarized a lot of data from all the projects we had done in the US and others had done. And then we summarized all the projects that we had done in Brazil, basically asking this same question: in time AI protocols, how important is it for a female to show estrus before or at the time of AI in these programs for fertility? And if you look at it, I think it's pretty striking. In Brazil, which they utilize different protocols, okay, you can see a stair step in regards to increasing fertility as you increase the patch score from basically not having much estrus expression to having it. And then in our US population, you can see when you go from this lowest patch score to this patch score, big differences in fertility. And I'll just point you to this. Look at what those averages are. They're very similar to the numbers that Mario showed. There's very similar to the numbers that I showed. It's about 50%. So when we mix it all together and we take this population that shows estrus and don't show estrus, you get that 50%. To get above that, you start to cherry pick those animals, and I think we see where that comes from. So also, big thing for us is in these animals that do not show estrus or have low estrus expression, they also have increased pregnancy loss. So not only do they struggle to get cows or get pregnant, they also struggle to maintain the pregnancy, which is like a double whammy, right? If you can get her pregnant, but then she loses it, it's almost worse than never getting her pregnant. And so at that time, we were scoring these patches like this, and utilizing this approach. And one night, Boyd Dingus and I were in Austin, Texas, at a bar at I think an IATS meeting or an AETA meeting. This is a true story. And I told Boyd that we weren't smart enough to continue to score the patches like this because there's too much variation. Like, what does this mean right here? Is that a 2 or is that a 1? So Boyd and I devised this plan we'll just put a black dot in the middle that would tell us when 50% of the patch was rubbed off. And the joke was that it's for the 50% of us that can't tell what 50% is all it is. So it's basically a technology to tell when we get from this to this, basically going from a patch score of 2 here to a patch score of 3 and 4, right? And so if you look at the data behind it, you can start to see situations where you can utilize this in a management system, right? So let's say you have cows that come in and they all have patch scores of 1. Okay, this black dot's now removed. Well, if I've got $75 sex semen sitting in the tank, or I've got $20 conventional semen, the strategy would be to not put a $75 straw of sex semen into this cow or into this heifer. But in the percentage of the population that showed estrus, maybe we can utilize a more expensive straw semen and develop some utilized time AI, but minimize your risk behind the cow that day to make a management decision that's going to be the most efficient at getting that cow pregnant. So it's not like we totally abandon her, but we cut our risk in what we're doing from a financial point of view to basically minimize what the outcome might be, right? Just an idea to throw out there. And this is one thing that a lot of people have worked on. Jordan Thomas at University of Missouri has shown this really nicely, where if you look at the idea of utilizing fixed time AI with delaying AI in the non-estrus females, okay? So the animals come in for the normal time AI, they don't show heat, so we can give them a GnRH surge, we induce them to ovulate, they ovulate 30 hours later. We delay insemination by 18 to 24 hours. And then at this point, you start to overlay the sperm and the eggs lifespan. Now, there's a issue with this. We have to work the cows again, right? But it fixes the problem of overlaying those two situations. So what I'm saying here is there's different strategies to accomplish what our goals might be. So if our goal with our producers or whatever situation we might be working in is to not work the cows again, well, then you make a decision in the chute on how you breed them. If the goal is to maximize fertility of that single ovulation, I don't care if I got to work the cows again, then we give them GnRH and we bring them back 20 hours later and we inseminate them. And the data shows quite nicely, Jordan has showed this over and over again, in the non-estrus females that receive the GnRH and delayed AI, you have an increase in pregnancy rate to the ones that were just given fixed time AI. He's shown that in conventional semen, and he's also shown that in sex sorted semen with the split time AI. So again, it's not a strategy to ignore. It's a strategy to think about what fits. It's not a one size fits all. It's about what fits that population of animals and that producer the best to maximize fertility within that given herd. So you see that, and one of the things that I would say is oh, go ahead, Luke.
I have one quick question. What does data tell us about the fixed time AI? Probably those females that come to compete on the early side versus later, and if there's any, does that tell us anything about their fertility or their fertility?
So the question is, what is the difference in animals that show estrus early versus show estrus late in regards to their fertility and their ability to maintain a pregnancy? And it comes down to a couple situations, and I'll just answer it from this point of view. A lot of that variation in estrus response is based on what stage of the cycle those animals were in, whether they had a corpus luteum that was present or not, and all of these other factors of progesterone, et cetera, that get into a lot of minute details that become very complicated, whether they're 2-wave or 3-wave cows, et cetera. There's no evidence that would suggest that if a cow shows heat very early or very late, depending on when in a fixed time AI protocol, if she shows heat way too early, the chance is you're not going to get her bred because they're not going to overlay. And we've had situations like that in different protocols that we've evaluated data from, that timing of AI has to be adjusted, right? All the time AI protocols at some point started with estrus detection to determine what's the optimal time. And as we discuss new protocols and new protocols come online, a lot of refinement still has to be done in regards to the time of AI and what's happening. So it's a really good question. And I think that it's really based on the physiology of the animal leading into that. Other questions? Yes.
Has there been any research done to giving a secondary injection of GnRH at like day 7 to day 9 post time AI to create a accessory pregnancy rate?
Yeah, really good question. So I'll answer it and then I'll let Mario give his take on it as well. So there's been a lot done, a lot more done in recipients than in normal AI. So there is, if you look at the data, there's been a big meta-analysis summarizing all of it, and a lot of it's also been done in dairy. I think there's a 2% or 1.5% difference in that data when you look at it, and it's depending on how the accessory CL is formed. But one of the big problems is that if you ovulate the accessory CL on the opposite side that the pregnancy is generated in, you run the risk of terminating the pregnancy if that CL regresses. So it's a little bit of a problematic situation. There's been a lot of work done with progesterone. Mario's done a lot. I'll let him speak to that. And when he finishes that, then the big question that Mario's going to address, so we're going to leave here all saying, is what is the influence of Bos indicus? How much Bos indicus does it take for an animal to act Bos indicus? Not act from the sense of run you over or something like that, from a physiology, reproductive performance point of view. Okay, so Mario, the progesterone question, and then we're going to hear the Bos indicus story.
That's a good question. He gave already the answer. So if you take a look at that meta-analysis, it is very clear. The overall response is a benefit of increased pregnancy when you have an accessory cell of 2 to 3%. Now there is a variation. There's some studies that was worse. There were some studies in which there were no differences. There were studies that were like a 30-40% increase in pregnancy rate. Usually these are the ones with like 15, 20 cows per treatment. So a very small study in a very controlled situation will give you a result that's not consistent with the mean, and the mean of many studies, which was that meta-analysis that he talked about. In Brazil, there is a drug that's available, which is an injectable source of progesterone. So it's an excellent opportunity to provide supplemental progesterone at the very beginning of gestation, like between days 3 or 4 after AI. You give that boost of progesterone through an injection, which is long lasting, to try to maximize the conceptus growth and to maximize fertility. Does that make sense to everybody? That's the idea of supplementing progesterone, like insufficient progesterone being a cause of lower pregnancies. I spent a lot of time using that drug and studying that. And again, you have a diversity of results. In some experiments, we had a 10% increase in pregnancy rates. In other results, we didn't have anything. The biology of that is complex. In one side, you make the conceptus grow more, so that's beneficial for pregnancy maintenance. In the other side, you make the uterus really nervous, wanting to produce prostaglandin and cause CR regression. Your end result is a balance. Which of the two situations is the one that's going to dominate? It's going to be the uterus more nervous, lower pregnancy, or going to be the bigger conceptus making more interferon tau and signaling better its presence that will increase pregnancy. The end of that battle is a tie. So I give up on it. I don't recommend it. And if you want to do it through GnRH in accessory CL, you can expect on average of a lifetime to have a 2% increase. Don't do it. Sorry, guys. That's my sincere take on that. Very good. So let's go back to our multi-breed herd. And you guys are, with luck, you're going to hear the first audience that are going to hear this complete story. We're just finishing the paper. The co-authors are reviewing it, and we'll submit it to publication hopefully next week. And the man behind this paper is Dr. Tiago Martins. He did a PhD with me back in Brazil, and now he's finishing a postdoc at University of Florida. We were working together then for 7 or 8 years now. And he just took a position at Mississippi State, and he's a great guy, and he's behind the summarization of data that I'm going to show to you. So I told you that this herd is a controlled admixture of Angus and Brahman, and it's been around for 30 years. And the records, because it come from the University of Florida, right? It's a research institution. They have been kept for 30 years. So Tiago, with his mathematical skills and his great intuition, had the idea, let's analyze 30 years of data and see if we can really measure what is the Bos indica's influence and fertility. Because this is the unique opportunity. Most of the experiments you see on this, okay, we're comparing an Allure to an Angus, or maybe one crossbred, or different situations. These cows, this herd is in the same place at the same time. So it's the only one of the few herds in the world with these characteristics that allowed us to ask this specific question of what is the Bos indica's influence on fertility. And here we go. We're going to get straight to the end here. So these are the proportions of Bos indicas. So this is the Angus, or almost all Angus. Here, there is the Brangus category in here too. And here will be the more of the Brahma proportion. So to that artificial insemination, to the same protocol, and again, it varied along those 30 years, but on the most recent years, it was the protocol that I showed you before, the 7-day co-sync. It will be about 52% if they are Angus. That's the fertility to that AI. And you go down to as low as 37% if they are Brahmins. Same protocol, everybody together, everybody gets an AI, and that's the result. So of course, what we found was that the more Brahma you have, the less fertile they are to that artificial insemination. However, after that 90-day breeding season, it varied a little bit along those 30 years. So after that AI, there's a 10-day break. Bulls come in at a rate that's acceptable, bulls to cows, stay for another 80 days, and then they are removed. 30 days later, we do a final preg check. Pregnancy rates to AI plus natural service. Okay. So by the end of the breeding season, you can be an Angus, you can be a Brahma, you're going to get pregnant at the same rate. You can see the numbers there. So it's a big number. And again, same herd, same situation across the years. This is what we're going to find. So hopefully your minds are already thinking and you're thinking, what does that mean? There is no inherent infertility in the Brahmas. They all have the capacity to get pregnant. And as more Brahma you get, it doesn't mean that you're going to get less fertile. It's exactly the same. There's no difference here. Then Tiago went ahead and measured what is the impact of that indicus influence on the capacity to get pregnant to that AI. And then what he figured out is that it goes like this. So this is 0 bus indicus. This is 30 seconds of bus indicus, so completely Brahmas. And of course, the fertility, as I showed you before, the fertility to that AI is less as the more Brahma you have. And that's calculated to a 0.5% lower likelihood of getting pregnant to that AI at every 130 seconds you add in bus indicus influence. So I'm pretty excited about that. It's a number here that, you know, it took a lot of animals and a lot of time, about 6,000 of them, but then you have a measurement, and then you can know. If you know how many Brahma blood you have in your cattle, if you can plug in that equation and say, okay, this is how much pregnancy I'm going to get to the AI. Are you thinking why? Yeah, me too. That would be a classical way that reproductive physiologists like to see pregnancy data. So along the breeding season, you can see that the ones that are mostly Brahma, they take longer to become pregnant. But then again, at the end, they are all pregnant at about the same rate. And the ones that are more on the Angus side, they get pregnant earlier, and then they will remain with that high pregnancy rate all the way to the end. If you have any questions, please interrupt me. Some explanations. So then, yes.
That have the fixed time they like just the Estrus expression.
No, that will be that pregnancy rate you're talking about. So that pregnancy is the that pregnancy. So right here in the beginning would be the pregnancy to that AI, of course, and then as the AI finishes and they are bull bred, then they keep getting pregnant along the breeding season. No.
Your previous slide, the pregnancy, that living in the previous one. The pregnant to AI, is that just Estrus infection, or does that have the forced breeding in it also?
He has the forced breeding on him as well. Thank you for that question.
Mario,
Yes.
did you use that same bull for 30 years?
No, the bulls are changing.
Full effect of violence over time or fertility. Different bulls throughout 30 years of work.
Yes. So the bulls are mostly in-house bulls. They are from that same herd. So they are not even the AI bulls. They are collected and we use them in the program. So it's not the same bulls every time, of course, but you're right. There'll be an effect of bull. It was put on the model. I can take a look at the paper and tell you more specifically about that.
Has the gestation or the postpartum been laid over these different percentages?
Yes, I'm not sure if I'm going to show you that data here, but it is on the paper. I think it might be. No, well, I'll have to get back to that table to you because of time. I didn't put that. One possible explanation is, okay, I know what's happening here. What? Oh, yes, Joe.
Question, Mark, can you go back to the, okay, and tell me if you've done this or not. If we're looking at the survival curve and we're looking at 81 to 100% ranges, which is the black line on top, right?
Yes,
Okay, and if we look at the separation between that line to the line on bottom, which I'm assuming is 0 to 19%.
correct.
Ranges. If you truncated that at 90 days and then did an economic analysis, where would you think the advantage would be in percentage Brangus in University of Florida?
If we truncated that, right,
Not 90 days,
and did an economic analysis.
did an economic analysis, what I'm looking at is the spread between the 81 to 100% Brahmin and then your 0 to 19%. In the Florida situation,
Yes,
it appears that there's value from this slide for having a lower percentage drop. Does that make sense?
correct. Oh, yeah, yes, yes,
Want to argue that? That's what it appears to be.
yes. It makes sense. It makes sense.
And then that will tend to go along with this idea of cows getting pregnant sooner and having calves sooner than next season.
Correct. Yes. I agree. Those guys here, they would not survive in many situations in Florida, specifically if they went more, if we go more to the south, when it's going to be more hot and more extensive. So they're here as a research model, and of course they have been adapted to our situation, and they will produce more as they are adapted now. Okay, good. So what will be some explanation? So we think, okay, the Brahmas, they are known for high on estrus. So a high proportion of cows will start the breeding season while they are not cycling yet. This is why it takes them longer to get pregnant. That's why their fertility to that artificial insemination is lower, because there are less of them cycling. This is typical from Brahman. But then, yes.
We had a quick question, Paul. Could you repeat what NS and AI plus NS means on that previous slide?
Yes. Here. So pregnancy to AI, that's the pregnancy or the proportion of cows that got pregnant to an artificial insemination. And then the second one is the total pregnancy, which is the pregnancy to the artificial insemination and the pregnancy to the subsequent natural service. Thank you. So then here just on 1 year that we were able to really put our hands on that herd. So the numbers are lower. We examined the proportion of cows that had the corpus luteum at the beginning of the synchronization program, and there was no difference, regardless if they were more Brahman or more Angus. The amount of cyclicity was similar. So at least for that year, there was not an explanation for why the Brahmas took longer to get pregnant, why they had lower fertility to the artificial insemination. I'll go back to that slide. Then when we look at Estrus response, that gave us some clue, and we're coming back to Estrus again, which is to that same protocol, the more Brahman you have, the less cows will respond showing estrus. So regardless of the fact that they did have a corpus luteum and they were cycling about the same proportion on the beginning of the protocol, that same protocol doesn't work the same on inducing estrus on cows that have more Angus, that have more Brahman. The protocol didn't work the same. It works very well for the ones that are mostly Angus. And actually, most of the protocols in beef cattle, they have been developed in more Angus and more Taurus kind of cattle. And they just do not elicit the same amount of estrus, specifically if you go down to the more of the Brahma. I'm not going to talk about it. It's kind of expected, which is regardless of breed, what happens to estrus response according to the category of the animal. So from nulliparous to pluriparous. And then Tiago again did the same exercise that I showed you before, and he showed a decrease of 1% in the likelihood of showing estrus to every 130 seconds of Bos indicus genetics that the animal had. So it is the same protocol, but they are less able to respond showing estrus. And we discussed before that the estrus is highly associated with fertility. Now, this is what it is the intriguing part. This is the so by now everybody's about the same. So what can be happening to the more Brahman? So this is the diameter of the not the pre-ovulatory follicle, but the largest follicle that you have in the ovary on the day that you remove the CIDR device. So you regress the CL with a shot of prostaglandin, you remove the CIDR, but on that same day, you took a look at the size of the follicles. And then what you can see is that the animals that had more Angus, they had a larger follicle compared to the animals that had more Brahman. So that could be an explanation. Yeah, you can say, yeah, but the Bos indicas, they have smaller follicles. Sure, but you see that more when you compare like a Holstein with an Elora, for example. But here, it just means that the follicles grew less to that same protocol. Maybe because of a greater susceptibility to the progesterone that's there. Progesterone is really inhibitory. The more Brahma you have, the more it inhibits the follicle growth. So the result was that by the end of the protocol, we had a larger follicle for the Angus, and that's significant compared, for example, with the more heavily Brahman. And that probably explains the smaller, the less ability of the more Brahman cows to show estrus and to show lower fertility at the end of that protocol. Does that make sense? There are more details. We calculated a 21 rolling pregnancy rate to this cattle. It takes on average a full estrus cycle, 21 days more for a Brahma cows to get pregnant compared to a more Angus cows, and more information on that paper. Hopefully it will be available soon for you all to take a look at it. If you want to take a look at it before, I can share also and we can discuss more.
So because we are running short on time, and Mario and I brought 150 slides because we didn't know what people were going to want to talk about, and we had a few points that we wanted to talk about. I'm going to rip through. Well, I lost the ability to edit it. So one of the things that, and we're going to take some questions here. So we're going to talk about sex semen resynchronization, but unfortunately we're running out of time. I'll be happy to discuss this with people. But the thing I wanted to end with is, we have a lot of tools that are available on the beefrepro.org. So the sync planner, you can download the Excel file. You can use that to put together calendars, strategies, etc. And very shortly, we're going to have a web-based version of this where you will be able to go to the web page and do all this online, select out what kind of what type of animal, what type of breed, what type of AI, time AI, split time AI, all these factors, and generate calendars in the exact same way that you can with the estrus synchronization planner, but in a lot easier sense. Okay. So I just want to end with that. Mario and I are going to take some questions. These are the take-home points. And I think that, protocols were developed to maximize estrus expression. And we're really fortunate that in a lot of these protocols, we do have good estrus expression, but we know that in the animals that don't show estrus, we struggle in the fertility in them. And I think that that's where we've got to think about the management strategies and what we utilize. Estrus synchronization is a powerful tool, not only for AI, but natural service. It's not a one size fits all. Okay, different strategies work for different producers. I was going to show the sex semen work that Nikki, Cliff, and I and Pedro did to show good results with sex semen. There'll be changes to the protocol sheets coming out to update that. Viable options, split time AI is a viable option. Resync we were going to talk about, but ran out of time. I think that's a next viable option to get 2 AIs in animals. And ask for help. Ask for help. If there's situations that you're struggling with, ask your local extension, your local AI companies, whatever it might be. And most importantly, we have this Ask the Expert tab. Ask for help on there. When you do something wrong in a protocol, if you ask the right people, you can usually fix the mistake and salvage the protocol. If you continue forward, you're going to have a problem. So it's recognizing that you made a mistake and just asking. So Maya and I really appreciate everybody, and we'll take a few minutes for questions here, about 5 minutes before we have lunch. So questions, anybody, discussion points?
Been doing it for quite a while. AI, it's my work for 40 years. And when I found 80 or 80, right to AI. Halloween, I'm supposed to read 8 o'clock in the morning. Like 4 to 8 o'clock. Is I spent all this money. I got semen lined up. I got 8 cows showing. Never had that kind of money. Only 8 cows showing you 80. I don't know what to do. Should I just cancel, start over? And so I had a discussion trying to get this overlap. I said, I'll tell you. Going to where you're all touch this sheet. Right now, before we go to bed, run all through the ones that haven't shown you and get them just around, and we'll time out a record. I do a fetal section and come up apples and bird at 75 in the day, 60+% etc. He said, wow. He said, so now every last 6, that's what he did. Just trying to get that period.
Yep.
I'm just saying that.
Yep.
People might have this.
Yep. So I'm going to just repeat this online. So the comment is about increasing fertility when you have poor estrus expression leading up to an AI, and the idea of, almost utilizing a split time AI where you give GnRH and then breed those animals, which would be sort of the traditional idea with the offsync protocol, which we know has an increase in fertility, but also has an extra animal working. So again, it comes down to that balance of, do you work those animals again, or how do you manage them? And I think that's the strategy that comes into play. But again, if you know estrus expression leading into it, you can make those type of decisions on the fly as you're working through these protocols. So really good point there. Questions? Yes.
So in a resync, or y'all gonna get that, can we get that information?
Our slides are going to be uploaded online. Yep. Yeah. And so, Mario unfortunately has, Yep. So Mario has a lot of really good data with resynchronization with Doppler. That's a really nice story. Pedro Fontes also has some, and I think Pedro will talk a little bit about it in his section. But there's a lot of opportunity there as the technology gets better. Yes.
We're talking a lot about the predominant influence, and the more the percent, the smaller those follicles are. Are they notorious for having less follicular waves, are they more to 2-wave cycle? Is that impact maybe that follicular growth too?
So they usually, the question is on the follicle development in Bos indicus animals. They usually start with a larger number of follicles. They recruit a lot more compared to the Bos taurus. So for people doing OPU, for example, for doing in vitro embryo production, you collect many more oocytes from a Brahma cows compared to a Brahma cow compared to an Angus cow, for example. But then after that, everything is approximately the same. They will grow, one will be selected, one will become dominant, and that dominant follicle will ovulate when it reaches its right size. 11 and a half, 12 and a half, 13 millimeters, if you just let it go and do it spontaneously. 2 to 3 waves, there's no difference between Taurus and indicas as far as I'm concerned. It's much more from cow to cow, from cycle to cycle. There's not a trend. The biggest difference it will be on the amount of follicles that are recruited between the two kinds of breeds. I don't know, Kai, if you have something else on that.
I would just, say one of the reasons that we chose to kind of emphasize this idea of Bos indicus and Bos indicus influence is I think most people in this room recognize that 70% of the cattle around the world are located in tropical, subtropical environments with a heavy Bos indicus influence. And so we're in San Antonio and in Texas, and if you look at the Bos indicus influence around here, and I think a big opportunity is to increase the reproductive efficiency and reproductive management in Bos indicus influence females, both from a producer and a company industry point of view. So what are some strategies to make that happen? And we're going to have to think outside the box and do things that are maybe not as conventional as we've been doing in the past to achieve higher fertility, maximize fertility, and recognize that if we put a Bos Taurus animal in that same environment, most likely she's going to struggle. So time for one last question. Anybody? Okay, with that, we'll thank Mario for being here and helping us.
Thanks, Kai.